Hello, this is Dr. Lori. Welcome to this new topic. We are going to be studying for the next few videos statistical inference and hypothesis testing. And so the big picture here is that we'll be looking at the research process in this video. Then we'll be thinking about specifically about the conclusions that we make based on that research process. And then we'll get a little bit more detailed with the hypothesis testing procedures. So this first video, research process, I'm going to be focused on thinking through how interpretation really fits in with the big picture of research. So as you remember, the research process is to ask a question, and then once we know what question we're trying to answer, we design a study, then we collect the data, then we analyze the data, then we interpret and share, and often that interpretation leads to new and exciting more questions that we would like to answer. So, in this whole process, this idea of coming to a conclusion for our research really is what we're focused on. Now, it's related to a variety of other concepts, even though what we're talking about is interpreting the results through the hypothesis testing procedures. We are relating this to the other parts of it. So specifically in the study design, if you remember, we start out with a population. And so you can imagine this large group of people, but we can't study all of them. And so we select a sample that we're going to study. We collect data on that particular sample and can calculate some statistics. But then what we try to do is infer back to the population parameters. This process right here, this inferring, we take the statistics and we try to say something about how that relates to the whole population. That's what we're doing when we're coming to a conclusion here. And so this process of inferring from the sample that we collected back to the larger population so that we can say something about the larger population really is key to this whole idea of coming to a conclusion. Also, if you remember, when we're analyzing data, we come up with, often we have descriptive statistics, so we're summarizing, usually one variable all by itself. But then there's also this notion of inferential statistics, and I'm just going to abbreviate IS, and that's where we're looking at relationships. Pay close attention to that word, relationship. Because here we are looking at two or more variables. So we want to know if those variables are related to each other. And so these inferential statistics really are what we're coming to these inferential conclusions about. So remember here with analyzing data, the whole idea is that we want to convert data into information that stakeholders can use to make decisions. Well, here's the decisions that they're making. They're making conclusions about what the study is showing, and so then they can apply it in their particular situation. So let's talk about this inference for just a minute. I like the Webster's definition of inference. It really has to do with statistical inference, and basically that is a conclusion that is reached based on the basis of evidence and reasoning. Here's the evidence that we get if we come up with inferential statistics, and the reasoning is how do we interpret what we have summarized with our inferential statistics. So inference then is the process of taking these inferential statistics and converting them into something that makes sense. So let's think about these conclusions that we're making. Let me scoot that back over. Let's think about the conclusions. So here's our conclusion up at the top. Now we're going to talk specifically about those conclusions. Here's our conclusions. We're making conclusions. We're going to make a decision. So When we're making a decision in statistics, basically there are two possible options. One is that I'm wrong. We hope not. That's called an error. We don't want to be wrong, but that is always a possibility. The other possibility, and this is what we're hoping for, is I'm right. I drew the correct conclusion. And there are a couple of conclusions that we can come up with hypothesis testing, but let me go one step further with the I'm wrong and I'm right. There are a couple of reasons that I could be wrong. And so, and this is going to be key to what we're doing with inferential statistics, because really what we're looking at is what are the chances that I'm wrong. So I could be wrong by chance, or I could be wrong because that didn't come out very well. Because of some kind of a bias. And this being wrong by chance is called random. And here's this word, error. I was wrong, random error. If it's because of bias, then that is called systematic error. And we're going to definitely be talking about bias and systematic errors as we go through more of the class, and specifically with each of the different kinds of study design. As a little aside, this systematic error can occur because of the way we select our sample. So who do we choose to be part of our sample? This systematic error can happen because of the way we measure things. And so what we're talking about right now, this whole thing about statistical inference and hypothesis testing, is not talking about systematic error. We're not trying to delve into the things that have to do with bias or systematically being wrong. Here's what we're actually hoping for. We're hoping that our conclusion is actually correct. And I can be correct for two different reasons. Again, I can be correct because those two, remember I'm looking at the relationship between two or more variables. Those two or more variables are related to each other. They're associated, but it's not causal. But not causal. And the other option is I could be right and they are actually causal. So we're going to talk about causality, causation. What between those two variables, does one of them cause the other one? And we'll be talking about that more when we talk about different kinds of data analysis and study designs. So I could be wrong, I could be making an error, I could be right, we hope for that. It could be associated or it could be causal. So we are, for the purposes of statistical inference and hypothesis testing, we live right here. This is what we're talking about. We're talking about why could random error infiltrate our particular study. So we talked about the fact that we're looking at two or more variables together. There are a couple of different conclusions that I can come up with. So one, I could say there is no relationship between my two or more variables. And the second conclusion that I could come up with is there is a relationship between my two or more variables. And I'm going to specifically be giving examples that have two variables. We'll talk more in the future about how that can expand to be 3 or 5 or 20 or however many variables. But for the purpose of simplicity, we're going to talk about just two variables at a time. And so let's give some examples of what that could look like. So specifically, one of the easy examples to conceptualize is to think about the relationship between two continuous variables. So let's imagine that we want to investigate the relationship between height and age, and we're looking at little kids. We know that when kids are little tiny, maybe they're 1 or 2 years old, they're shorter on average than as they're growing up, they get to be 10, 12, 14 years old, then they tend to be taller. So if we were looking at this relationship between height and age, let's just say that these are for like 2 to 12-year-olds. So we would imagine that as age goes up, height would also go up. So as age is low, these little dudes are shorter, but as the age of our subjects gets higher, then they tend to also be taller. And so we're in this particular example, we're looking at the relationship between age and height. Specifically, if I know something about a person's age, does that help me know something also about their height? If they're related to each other, then height is not the same for every single age. If height was the same for every single age, then those two would not be related to each other. So we would say that that's not the case. As children get older, they also get taller. So those two would be something that intuitively we know are related to each other. Here's another example. Let's say we want to look at the relationship between height and gender. And this time we want to, I can spell height, G-H-T. This time we want to look among maybe adults. And so as people are fully grown, are men and women the same height? And I think based on experience, we all know that men tend to be, on average, taller than women. And so here we are, we're looking at this relationship between these two variables. If I know something about a person's gender, could I then also know something about the chances are of how tall they are? If men and women had the same height on average, then knowing their gender would not really help me know something about their height. So that's another example. Here's the third example, and we'll probably be using this throughout this series on statistical inference. Let's say that we know the average height of 12-year-olds who live in California. Let's say that that average is, and I'm just pulling a number out here for the purpose of having something. Let's say the average is 150 centimeters. The average 12-year-old in California is 150 centimeters tall. Well, let's say that then I want to know something about the average height of 12-year-olds in a specific location. We could choose a city, we could choose a county, we could choose something that's completely not even related to California. Maybe it's a whole nother country. But let's say we are looking at the average height of 12-year-olds in Coachella Valley. We have a connection with that particular population. It's a farming community, and maybe something about that community really affects how tall the kids are, or their growth patterns, or something like that. And so we're looking at that relationship. So our variables here are, well, where do you live? Are you specific to Coachella Valley, or are you just part of this group that's sort of like the average of all of California? And then the second variable is height. If I know something about where you live, if I know that you're a Coachella Valley person, does that tell me something about your height? So this is average height. Does that are those two variables related? If they're not related, then the 12-year-olds in Coachella Valley are going to be the same as all the ones in California. So if there is some kind of relationship between where you live and how tall you are, then we would say then that these 12-year-olds who live in Coachella Valley are not the same height as the average of what we see in California. We know a lot of times we talk about how your zip code is more predictive of your health than your genetic code. So These are the kinds of things that we're looking for when we're looking at relationships. First of all, there could be no relationship, or maybe there is a relationship between those two variables. And if there is, we want to be able to spot it. We don't want this random error to get in the way of what we're looking for. So that concludes this big picture overview of the research process. Thank you for joining me.